Kashyap Wadavu, ID number 187724243. So this is my video for the code walkthrough. So this is the application code, and this is the network2.py file. So I have added functions for derivatives and calculating quadratic cost. This is for cross entropy, and this is the derivative for cross entropy, and this is where I took care of division with zero, and this is for log likelihood, and this is its derivative. It's same trick to take care of division by zero. And then this is the sigmoid function. Then this is softmax. This is the function. This is where I took care of division with zeros, and this is the derivative. And then this is tan h and its derivative, and value and its derivative. After that, I had to edit the feed forward function so that it considers activation hidden and activation output parameters so that it applies hidden for the hidden layer and output for the last output layer. And I had to do the same thing in backprop function in the feed forward phase. So this is where I did that. So use the hidden for hidden layers and output for output layer. Now I update the updated mini merge so that it takes regularization into consideration. So for L1 and then for L2. So this is where it changes the updating the weights if there is regularization. And then I edited the total cost function so that it takes regularization into consideration. So using the sum of the square of the weight for L2, the mod value of the weight for L1. And this is the application code. Now restart the current. I'm going to run the code to look at my experimentations. This is for the sample data, and then this is with iris trained tester data sets and sigmoid and quadratic for cost. And then this is for sigmoid and cross entropy cost. And now this is for sigmoid and log likelihood. And this is using hidden sigmoid and softmax for output layer. And this is using value for hidden layer and softmax for output and like log likelihood cost function. And this experiment is it's using value for hidden layer, softmax for output, and cross entropy cost. And for this example, it's using tan h for hidden, sigmoid for output, and cross entropy for cost. And here it's using tan h for hidden, and tan h for output, and cross entropy. And since it's not using the quadratic cost, so my code is going to use sigmoid for the output layer instead of tan h. So the results are the same, which you can see for this example and this example. And now this is using sigmoid with quadratic cost and L creative decision with a lambda value of 3. Then this is using L1 degradation with lambda 3. Using L2 degradation again with lambda 3 and value hidden and soft max output. Using sigmoid and quadratic function, cost function, and using this iris 42073 network instead of the iris network we used before. And this one is using dropout. And that's it. Thank you.